This is proof of people in office hours, okay? Make sure you guys come to office hours. Say hi.
Hi.
Okay, so we're going to graph secant now. Same type of situation where secant, again, is 1 over cosine. So we know that when we have zeros, we're going to have asymptotes. So we should have an asymptote here and an asymptote here. So secant, it's 2 pi as a period, and so what we're going to do is the same reciprocal process. Suppose we have y equals secant x in blue, this is y equals cosine x in black. Okay, so how do we draw y equals secant x? Well, when the output is 1, we do 1 over 1, we'll still get 1. Okay, we're going to approach 0 negatively, which means we approach infinity negatively. We approach 0, it means our denominator gets to be secant x is 1 over cosine x. Our denominator gets closer and closer to 0 negatively, which means we get larger and larger values negatively. And similarly, we're going to have a height of 1, so we'll go to infinity as we get closer to 0 positively, and so forth. So we're going to have these things over and over again, and you can see, you know, if you take it from, say, pi over 2 to 3 pi over 2, so I've got another asymptote here at 3 pi over 2, you kind of copy and paste this type of situation. You know, this is black right here, so it's going to end up getting to 0 right there. You keep copying and pasting what's in blue over and over again, you get the graph of secant. And there it is, right there. So over 2 pi, boom, do it again and again and again. So this is the graph of y equals secant x. Okay, so tangent and cotangent. If I want to graph these guys, I got y equals a times tan kx. A is the amplitude, okay? K, you can always find your period by doing pi over k. Same thing with cotangent, amplitude. Find that value of k. Pi over k has your period. Again, the period of tangent, cotangent is normally pi. So pi over k if you have some factor k inside here that's k is greater than 0. So let's graph this guy. Y equals tan 2x minus pi over 2. One thing you can do is you can factor out the 2 first. So rewrite this as tangent 2 times x minus pi over 4. Now that x minus pi over 4 is just a shift. Okay, it's just a horizontal shift. So if we want to find the period, so our period would then be equal to pi over k. What's the value of k here? K is equal to 2, so our period is pi over 2. So we've got a period of pi over 2. Now we know what the normal graph of tangent looks like. It looks, you know, goes through that point 0, 0. But now what we're doing is we're taking that and we're compressing it down into something that has a period of pi over 2, but we're also shifting it horizontally to the right pi over 4 units. So instead of having 0, 0 is that kind of that point that the fluctuations change from say concave up to concave down. Now we've got that point, instead of 0, 0, we're going to have it at pi over 4, 0 now. So that's, and now our period is a full distance of pi over 2. So a full distance of pi over 2. So I'm going to have 0 and pi over 2 be my asymptotes that I need to approach. Again, I took, normally it was pi, right? Went from negative pi over 2 to pi over 2. But we compress that down because we have this factor here to be pi over 2. So now it's half as large, and we also shifted it over. Okay? So now we've got this situation where our graph looks kind of like that. And of course, we repeat it every pi over 2. So I've got another one right here, just like that. And we copy and we paste it an infinite amount of times. So this is an example of graphing this guy. And I think the key to this is being able to factor that out so I can get out what my true period is. Okay. Okay, so now we're going to take a look at cosecant and secant. Y equals a cosecant kx, y equals a secant kx. K is a positive number, okay, and a is our amplitude. These two things have period 2 pi over k, all right? Okay, so let's take a look at an example. We're going to graph 1/2 cosecant 2x plus pi over 2. What do we do with this situation? First thing is to do what? Rhymes with tractor. Factor. Very good. All right, so we'll factor it out. So we'll get 1/2 cosecant 2 times x plus pi over 4. This is very similar to the last one, but now we're doing cosecant. Remember, cosecant is the reciprocal of sine. So if you know how to graph sine, cosecant is really easy, okay? Now, our period here, so what's our period? Our period, again, is going to be, now period 2 pi over k, so 2 pi over k, k is 2, so we're going to have our period to be pi. Now, we're going to have a period of pi, and we're also having the shift of pi over 4 units to the left. Why left? If it's positive, we shift to the left. If it's negative, we shift it to the right. Okay? This 1/2, what this 1/2 does is this makes our graph wider. Okay? What that does is that stretches it out. Okay? All right. So let's graph it. Now, what's an appropriate interval? Well, if I didn't have that right there, then if I didn't have the plus pi over 4, then what I'd be doing is graphing this thing on a period of pi. It'd be the same thing, normally it's 0 to 2 pi, but I'd be shrinking it down and I'd having it from 0 to pi. But then I'm shifting it over pi over 4 units to the left. So over here, one color, I'll have negative pi over 4, and over here I'll have 3 pi over 4. Where am I getting these numbers again? Normally cosecant has 0 to 2 pi, right? 0 to 2 pi. We shrunk it down. Now it has a period of pi, 0 to pi. But then we shifted it over pi over 4 units to the left. Excuse me. Okay. So, asymptotes. We know we're going to have asymptotes. We're going to have an asymptote here. We're going to have an asymptote here. And we're going to have an asymptote right there. What's the value of this thing? Well, pi over 4. That's half a pi. That's half a pi. Okay, in the middle. Now, if this is the height of 1, and this is the height of -1, and I want to graph it. Now, normally, remember, if sine were to do something like this, okay, cosecant, just you kind of put, I guess the best way to describe it, like these little u's at the tops of each of those curves. So we put a u here and a u there. Now these u's that we create are going to be a little bit wider because of this 1/2. Okay, so what's going to happen here is we're going to have right here, we're going to have cosecant kind of approach those asymptotes, and because normally our sine curve on this thing would look something like this, okay, and then we're going to have one down here. It's going to approach, and it's going to approach, okay. So this is the graph of cosecant when what we do is we shift it over pi over 4. We've got this argument with a factor of 2, which changes our period, and then also we've got this factor on the outside that kind of widens it a little bit, which I might have done a better job doing, to be honest with you. I probably could have been a little bit wider, because what that does is that stretches it out a little bit more. So it's a little bit more like that. Okay? So this is a sketch of the graph. Again, it's not precise. I didn't put a lot of points other than these two, but that's kind of the way it looks.